Okay, for the recording, welcome team, session 14. So today we'll be talking about, I guess we just discussed about the deployment briefly. So we'll talk about another important topic, guardrails, and then probably touch on a little bit about the evaluation. um, and that will be session 14. So we have two more sessions next week, and then we'll wrap up the training. But anyways, that's not the end of it. It's just logical closure that, okay, we have gone through all the topics, covered, discussed the promised 16 sessions that we're going to do. But we will always continue this journey. As many of you know, you have been there in a lot of my previous cohorts as well, and you have seen the progression, how we are progressing, adding more topics, getting into more details as we go into cohorts. So even if we wrap up next week, we'll still continue our collaboration. You're still welcome to join the new cohorts, right? The next cohort, when we're planning, so next month, and then repeat all the sessions or whatever sessions you are interested in. But I'm happy, more than welcome, you guys to repeat all the sessions, the entire cohort again. Um, and bring in any of your colleagues, friends, references, right, who you think would benefit from this program. Okay, so that's about this. The next week, as I said, we'll talk about deployment, and we'll talk about MCP protocol and A2A protocol, and a few other protocols. Some examples we will demos also we will look at. Uh, there are a lot of other things to cover because, as you know, every week in the AI world, there's something new dropping in, right? Every month there is Cloud Code, there is Open Cloud, there is uh, Cloud Cowork, there is Vectorless RAG. So there are a lot of new things. There is skills .md that is coming. There are a lot of things that are coming in. So hopefully, I'm just trying to um, give you an hopefully some of these I will add it to my next cohort, and then when I explore and add it, you can, when you repeat the next session, probably you might learn something new, and some of the current ones I might drop or compress a bit to make space for the new topics to come in. But yeah, so that's about how we progress, right, going forward. We'll try to add all the new ones and then retire the old ones where we are coming up. So instead of talking about the RAG, talking about vector databases in 3-4 sessions, probably we'll move one, take out one, and add vectorless RAG there. That's the new concept that is coming in. Uh, so all of this, I'll keep exploring and adding going forward. As I said, you are more than welcome to um, join my next cohort as well. I'll send you a note, sometime today, and then you can pass it on to your friends and references. I'll appreciate that. Okay. Any questions before we start? No, all good. Okay. All right. So you guys have seen that note Ishrat posted that about the workshop I did at the UNT, Texas.
Yes, yes, Arun, I saw that.
Yeah, yeah. Okay. Yeah, I did that, I think, last week or before, yeah, last week, on 6th April. Yeah. It was
Oh,
very nice. About 40 to 45, about 45 students attended, the master's students who are from data science and AI in the UNT. So I did a 3-hour workshop. I mean, whatever we are doing, all of this, I gave an introduction, covered a high level, in 3 hours. So agentic AI, RAG, and all of more focused on how the AI is being used in the industry. And then there's another topic that I wanted to discuss about the actual use cases that we are working in the industry. So that is another session I want to take. But yeah, there's so many things to add. So we talked about all of that, right? So that was it was a very good session, and then I'm planning to do more, based on opportunities. Okay, so today we're going to talk about the guardrails. S- So what is guardrail? What do you understand about guardrail? I mean, it's all about. I can see here just this picture we're talking about. Here, what is a guardrail? Can anybody? Srilata, in general, what does guardrail mean?
Boundaries or instructions.
Boundaries or instructions? Okay. What else?
It's a it's a it's a way to control the input and output ports, or is it something like that where even in servers we have some of
Yeah,
the
it's more protect than control.
Safety valve.
Yeah,
okay.
it's about protection. So basically, guardrail, if you look at that, right? Guardrails, the name as it suggests. If you see on the freeways, you see on the guardrails on the side, right? What does that do? It protects you from going off the road, right? When the poor light or poor conditions or at the night, um, or there is a dangerous car, wherever there is, you have guardrails to protect you to go, the hilly areas or valleys, deep valleys. It helps you to protect, falling off from the road. Uh, you've gone bowling, right? And everybody has done bowling. That pins, 10 pins bowling one,
Yes.
right? So there is something, an option to bring up the slats for kids so that the ball does not fall into the side, that thing, and then go out, right? So when you can bring up the slats or the guardrails that you call. So which means that if it is going off the main flat surface, then it will hit that and come back, kind of. So it's protecting. So it's the same thing here in the AI world, because we are known to have a lot of hallucinations from the models, right? Models, we know they hallucinate a lot, and then they are prone to abuse, right? So we have talked about in the initial sessions, we talked about when we talked about the models, their strength, their features, and the limitations. We talked about how they don't have knowledge and external knowledge, or how they have knowledge cut off, and then we talked about hallucination, and then how they are prone to abuse. Basically, uh, users can ask questions which they are not supposed to. We had a lot of um, scenarios or cases about um, the unwanted pictures that it is like generating, or suicide advice, or mental illness, mental health, basically advice that people are asking these models, like there was a issue with Grok, then there was it with chat GPT and other things. There are a lot of more and more people are dependent or becoming dependent on these models for advice, which is not a good practice, right? And then the models are not supposed to give out that advice, those kind of advice about mental health or suicidal or any other stuff, which these models are not intended to do. So how do you protect this? Or hallucinations, a model is coming up with something that is not true, not based on the facts, then how do you protect the information? Example, the models that are dealing with the patient health data. So models have been trained on patient health. Maybe they have some data that they have seen about the patient's medical health or about the PII data, their SSNs, their date of birth, or their addresses, credit card details, or whatever. If any of them is stored, or phone numbers, and you don't want to give out to them. In our normal applications, we handle all of that. We do data masking, we do row level security, and all of that. So the same concepts we want to bring it here for the model. But however, the model is going to, so let's say you do a RAG and then you pull some information from the database about the customers and you send it to the model and the model sends it back. Now, between when this happens, you have to look at what kind of information is going into the model and what kind of information is coming out of the model. If any of this information has issues, the security issues like PIA data, as I talked about, like you can say code issues, like people are trying to ingest code or generate code which you don't want. Of course, sometimes if you are using code models, yes, you want to allow, but otherwise, maybe you don't want some unwanted text languages you want to restrict, or some unwanted company names or URLs you don't want to inject. Then SQL injection, you want to control. Somebody is trying to put in SQL into the prompts. So all of this, something you can do at system prompt level, something in the model has inbuilt guardrails, and something on top of that you add another layer of your own guardrails to protect this. So what happens in this, guardrails is basically, if you see at this picture, right, um, you have the model here, and then your application front end, UI or chatbot, whatever. So the user is asking a question and you send it to the model. So of course, there are a lot of things happen here. Maybe you go to the RAG, you get information from the RAG, or you directly give a question, or you do processing, you call API, you call tools, agents, whatever it is. So before you send it to the model, all of this context, you send it through some controls, input controls. So these are your guardrails. It's a scanner kind of a thing. Just think of it as an airport. When you enter, your all your luggage, your baggage is scanned, right? Security scanning. The same thing, it goes through the scanner, and then if it pass, then you send it to the model. Again, from the model, whatever the answer is generated, you're coming out. So when you're coming out, again, you have a security check and customs check, right? Scanner. The same thing, you scan the output and then you see if there is any such information, unwanted information. You take action, whether you want to send it to the user or block it or hide some of the information, mark some of the information and send it. So that's it. So before going to the model, you put a scanner, and after coming from the model, the answer, before sending it to the user, you add a scanner here. Okay. So that is both your input and output scanning. That's all about the guardrails. Now, what do you scan for? Right. So what do you scan for is the actual controls or actual guardrails that you build. There are a lot of inbuilt, some from hyperscalers, like if you go to Bedrock, if you go to Azure, these guardrails are already built in, and you can directly take it and just plug it into your pipeline like this, so that all input is passed through these controls, input and output. So this is off the shelf available. Then there are some products which, like this guardrails.ai, you can use it directly and then import and add those guardrails here. That's the second option. The third, you can write your own guardrails. It's just, if you look at, I'll show you the code base as well. It's just about writing code, some Python functions to take the input and process it and figure out if there is any unwanted scenario or unwanted data in there, and detect whatever is needed. So custom guardrails also you can build on your own. So these are three different options that you have with the guardrails. So if we go here, let's say open check this. So protect AI. So this is what I'm going to look at this today from Palo Alto Networks. Most of you may have known, in the US, Palo Alto Networks for security. So this library, it's just a Python repository. So it's from the Palo Alto, and then see advanced input and output scanners. They call it scanners. Protect your LLM applications from data leakage, prompt injection attacks, and much more. So they are model agnostics. Like obviously, you're not doing anything with the model actually, right? So you're processing your input data before sending it to the model. So you can put it anywhere with integrated with any model. So it doesn't. It's not dependent basically. Once you add a scanner at the output, you can send it to the any LLM framework. You can add this. It is easy to deploy just as a library or API. Okay. Includes extensive documentation with use cases and playbooks to secure your LLM applications quickly. So you have some of advanced input and output scanners. It's cost optimized, open source, low latency, high accuracy, all of that. Okay. Now, if you go to see actually the library, so protect a LLM guard, this is all it has. Okay. So in this is what we are talking about here. And then if you go, all you have to do install the library like we have been doing it, and then you will have all your scanners. If you see here, supported scanners, what are the so you can also use it as API. Okay. And you can also use ChatGPT, LLM guard, and then use call ChatGPT or whatever. But code base, if you look at scanners, supported scanners, if you see, these are like the prompt scanners. Prompt scanners are basically your input scanners, because input is the prompt, right? You're sending to the model. Input is always the prompt that you send. The prompt will have system prompt, user prompt, and then you will have context. Or if you have retrieved some data from the your RAG, from vector database, all that, everything is included in the prompt that you send to the model. So input scanners are called prompt scanners here. Now, if you want to see, so all of these anonymize is if you want to anonymize the data, remove references, you want to ban code, you don't want to allow code, ban competitor names in your company, you are not allowed to use any of the competitor names or references or data. Some substrings that you want to specifically remove, topics, you don't want to add some topics, for example, any topics about ongoing war or hate speech or racism or violence or abuse. So these topics you don't want the users to ask the model. You want to restrict them, right? In your company organization, you don't want to people use those kind of things, so we can ban those topics. Code, again, same thing. You can detect what kind of code is there. You can ban code or you can allow code. These are, I think, two different versions. Gibberish, some text um, which is not what you call deciphered or understood, processed by the systems, like some gibberish text if you want it. Invisible text. This is the most popular way to fool the models, right? You give a prompt. In the prompt, you add invisible text, like, in white font or whatever. And so you cannot see with the naked eye, but the model can still read it. So you can add some instructions in the invisible text. So that detecting that language, which language you want to allow, is it just English or multilingual? You want to allow Spanish, Arabic, or whatever languages that no, you want to allow. Prompt injection, that's what we said. Invisible text is also part of prompt injection, but there can be multiple different prompt injections like SQL injection, and how there are a lot of ways to inject a prompt. Um, it's like there is a trigger phase, right? So what it does is basically, I don't know if you have discussed about it. You know how the models are trained, right? So they are trained on the publicly available data. Okay. If you are able to just put your docs out there, on the internet, available the, for the models, for the algorithms to um, scrape and be trained on that. So you have a backdoor entry. Now the model has seen your data, whatever you have put. So when you are exposing your data on the internet, in the hope, that models will be able to consider that for training, you can put some hidden instructions in there, catchphrase in there, or you can do whatever. And the model, when it trains, it takes it. Now the model is trained, the model is released. Now it knows those catchphrase instructions that you have hidden in that. Now, when anybody is chatting with that and they hit that phrase, it goes berserk. It gives you unwanted output. So that's how you're breaking the models, backdoor poisoning. It's called LLM poisoning. Okay. So it has been proved that you only need about 1,000 documents, that are allowed, that are actually added to the total data set by the model when it is trained, when it is being trained. Uh, it is just like saying, penetrating the network or undercover, right? So you make your documents somehow become part of the training that the models is undergoing. And once they're in, it's a backdoor, you are in. So from there, once the model is released, you can trigger that catch phase, whatever you have put in, and then the model will execute the instructions. So those kind of things are available. It's called LLM poisoning. There are other various research ways that are coming up. How you it's basically how you can do the poisoning, or how you can exploit jailbreak, and different ways of how to stop that attacks, kind of. So regex secrets. If you have any secrets, like your keys, API keys, username, password, all of that. Sentiment, as I said, religious sentiments, or political sentiments, all of that. Token limit and toxicity. So several things that, again, output also most of it same. There might be some bias, JSON, malicious URLs that the model is giving you, factual consistency, if it is right or not, URL reachability, if those URLs, whatever model is giving, are they valid or not. So all of these you can check for. So you can pick and choose which scanners you want to implement for your particular code base. Okay. So these are the scanners. Now, if you want to look at Go, the code itself, so this will be something like this. Okay. Or let's say you want to go directly here, LLM card. This is the repository. And in this, you have input scanners and output scanners. So if you go on input scanners, then you see here anonymize. So this is same as what, okay, where did we go? Okay, let's open one more here. Okay, so this anonymize is just this code. So when you implement or use this anonymized scanner, right? So this is just the Python code that runs. So what it is doing is it's getting default entity types like credit card, crypto, email, IP address, person, phone number, bank number, credit card, UID, email address, SSN, all of these supported languages, and then it just does some processing. It also internally uses some ML and AI internally to do this. Uses the transformers, okay, machine learning models. So this is all just the Python related library. that is executed when you add the scanner. Okay, so this is the underlying code base. Similarly, if you want to, so PII entities and everything, if you want to implement anytime, if you want to implement your own guardrail, this is how you can write your own guardrails. This is a lot of Python code, uh, you know, uh, but this is how each scanner runs. So every scanner has its own code. So that is anonymized, and then you can check, let's say, ban competitors. So what you would do is you give a list of competitor names. Let's say, so this one should be simple. Okay. Uh, so this is a competitors sequence. You give what are the competitors names, list of the competitor names, and it just checks. Okay. Take the tokenizer, transformers, and that, and then say in the prompt entity word, and then it will check in the competitors. From the prompt, it will take the words. Simple, right? That's what we want to do. You want to scan the. Why is this happening? So, back here. So the crux of it is you take the prompt. From the prompt, you take each of the word, and then you search for the word in the competitors list. That's the whole thing, the crux of doing that. And then you will, there's a lot of additional processing that happens, and then that will give you a score of whether it is pass or fail based on the list that you provide. So it's same thing goes band substrings. You can do band topics, whatever you provide, and then you say code. How does the code work? So it will detect supported languages, right? So it will detect if any of this languages, if there is a code in any of this language, it can automatically detect, hey, there is some code in the prompt, and then it will give you. Okay, so that is about uh, the input scanners, output scanners, secrets. So these are all the plugins it is using, like AWS, Azure, to detect if there are any keys, right? So it will take all of this and then access key, API tokens, anything that appears in the prompt, it will detect all of that. Or it'll just, it'll redact and then put stars in that, mask it, and then say, give it to you. So same thing will happen in the output canvas as well. Okay. Questions? Guys, any questions? Are we good?
No questions.
Yes, sir.
Okay. All right. Great. Okay. Let's look at some action, right? Some uh, code. So we just go and install LLM guard. It'll take some time to get the libraries. So I'm just doing OpenAI API key. And then it's simple, like scan input, scan output, scan prompt from the import. Then you have input scanners. These are all the scanners I'm importing from the input scanners. Then these are output scanners that I am importing and vault. So OpenAI API key, we created a vault. So some of them anonymize and de-anonymize needs a vault object. It's simply, so we create that vault. Input scanners, list of input scanners. I'm adding anonymize, toxicity, token limit, prompt injection. So all of these. Output again, de-anonymize, no refusal, relevance, sensitive. So all of this output scanners I'm adding. Okay, so let's go ahead, add keys and access. Now import OS, OpenAI, input output scanners. So once we get that, so I'm creating a prompt. Okay. So in this prompt, I'm adding, say, name, email, phone number. There is another email here, IP address, credit card number, and so some work location company. Then what I'm doing is I'm doing a scan prompt. Okay. Scan prompt is this prompt. So I'm passing the prompt and the input scanners. So it will take this prompt and run all the scanners that I have in the list of input scanners that I added. And then it will give you a result score if the results are valid or not, a Boolean value, and this sanitized prompt, which is modified prompt based on your scanners. If the valid values is false, if it is not valid, then you print prompt and result score. And then it says what is the sanitized prompt. So we will see what's how it's coming up once you add all of these. It's done. Okay. All right. So then we are sending the prompt. So check here. Instead of, we are not sending the actual prompt to the model, we are actually sending the sanitized prompt, which is modified once we pass through the scanners. So that is what we send to the model. That's what we discussed here, right? So when it goes through the input controls and then we send that to the model. Now, once you send it, okay, and then you get a response. This is the response. Response dot choices message content. So we take the content into the response text output and then pass the text through the output scanners. So what do you pass the output scanners? The response text, the prompt, actual prompt that was sent to it, the sanitized prompt, and the all the output scanners that we want to pass the text through. So it will again give you a result score, results valid, and a sanitized response. Then we'll send the user the sanitized response, not the actual response that the model is sending. So that's all about. So before getting in and after coming out, you kind of do that. Okay. So let's run this. So it is like checking credit card is there. It's saying it's the score at 0.93. So there's a very high chance that this is a credit card number. It is giving 259 to 276, 257, 259, whatever these lines that it has identified as credit card. There's an email address starting at 91 to 104, 75% chance. Then there is email address from 143 to 157, again 75% chance. So it is detecting all the elements that we have added in the scanners, what we want to scan the input for. So found sensitive data in the prompt and replaced it with merged results. So type is person. Okay. It took person as one of the element that it has scanned and found. Email address as one element, another email address. There's a phone number. Then there is an IP address. Then there is a credit card. Okay. So risk score is 1. So very high risk score where it's kind of taking all of this, right? Now, it has identified all of these issues. Is valid, false. Scanner is anonymized. From the first anonymized scanner, it found it is not valid because it has all of this information. Then scanner completed. So then not toxicity found in the text result. So basically, if you look at this, right, we said in the scanners, we added toxicity. So then when it scanned the input, it said, where are we? Okay. So when it scanned the input for toxicity, it said it did not find a toxicity. So what did it check for? If you see male, is there anything related to male, like gender? It's checking for the gender bias kind of a thing, but it may not be totally true because if you found a label male, it may always not be discrimination. But yeah, that's one thing that psychiatric or mental illness. Are we checking? Are we does it have any content regarding to the psychiatric or mental illness? Remember, we talked about it just a few minutes ago. How the users are being dependent and for advice and talking about these things, which should not be allowed. So we're scanning for that psychiatric or mental illness information content. Insult, any insults, female again, white, which means like racism. It's checking for racism, white, black, whatever. Again, it may not be always in that context, right? But it still kind of checks. Label, religion for religion, Muslim, Christian, whatever, black, right? Obscene. So this is all homosexual, gay, lesbian, Jewish, threat, identity attack, sexual explicit, severe toxicity. So all of this it is scanning for. Okay. When you add a toxicity scanner, and then it will give you an output here. Is valid, true. So it said true because it says your prompt or your input prompt does not have any of these ones for the toxicity. Then okay, maximum tokens is okay, token limit, scanner completed, no prompt injection detected. So we looked at prompt injection, so there is no prompt injection in this. Scanner completed, we have a scanned prompt. Anonymize is 1 score, which means it found issues with it anonymized. Toxicity, token limit, prompt injection, it did not find anything. So -1, so that's fine. Now, sanitized prompt, make a sequence to add a new user to a database. Do we have this one? Yeah, make a SQL insert statement. This is the sanitized prompt. If you see here name, then it has redacted the first name, then just leave the last name. And then it redacted the email address. It replaced with it redacted email. This is email address 2, it redacted. Phone number, it has redacted. IP address, it has redacted. credit card number, it just left where he works. And that's it. So everything else it has redacted. Okay. So this is the sanitized prompt, and this is what we are going to send it to the model. Uh, then this is all of this is done. So another thing is, see here, anonymous has failed, but the option you have, you can take an action. Say if it has failed, do you want to send it to the model with redacted information, transformed prompt, or you just want to reject and stop? So that you have to take a decision when you add the code base here. Sanitized prompt, right? If result valid, then you can here choose to exit, or return and say input prompt is not valid. We cannot answer this question or answer this whatever. You can take that, or you can continue and then send it to the model. Then once you all that is done, max length, truncate, default to truncation, account number. So then it said in the output results, it again found email address, person, email address, credit card, all of this. Again, I think it is from the prompt that we sent. So here the output, insert into this, then it gave the SQL with the redacted attributes, not the actual attributes, not the actual values. So we can take this, we have to replace with the actual values if you want to use this. Sometimes if I have PI information, this is how it does. So it says make sure to replace placeholders and then use the actual values to the user database. This is how you can print, the actual values you can add after values, you can add this. Okay. So this is unredacted values when you have converted back with the original values. But that's how it's the scanner works, input and output. Okay. Any questions here? And this is another, same thing again, another one we are doing with the keys and all of that prompt, LLM response, different languages, fake headlines, delete SQL, same scan input, scan output. We are using the same scanners, and then just different prompt. And you would also get, different results, no toxicity, found sensitive data, and Python script, Arabic translation, fake headlines, delete from this is the SQL, right? So de-anonymize true, 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 sensitive is false. So you will get results based on whatever scanners you are adding for input and output.
How do you decide what scanners to use?
It is up to you totally, your use case, right? Whatever you are building. So again, there is a lot of lag when you send it through the scanners because it has to process input multiple times. For each scanner, it has to go through, right? So let's say if your use case in your company you are implementing, you can allow code, right? So you want to using it for code generation. So you can allow code, you will add code. Or for example, for PI data, definitely you will add that scanner for PI data everywhere for all your use cases. That's one thing. Hate speech, maybe you can add. But more again, you have to look at how it is performing in the test and then see if any data is leaking or if you're seeing any unwanted kind of output. Then you have to make sure that you implement those scanners. These are all the things that are available. Most of the things are automatically handled by the model itself. Like if you say the sensitive, no, not sensitive data, but this toxicity, right? For example, so this should be automatically handled by the models most of the times. Prompt injection also is handled most of the time. But again, if you're seeing any of that not being handled, then you need to add it. Specifically, if you have requirements, hey, I don't want to allow my users to use any language other than English. Those are requirements, right? Based on the requirements, you can add what you want to add to your scanners. If you have dealing with PII data, definitely I want to add anonymize. So it's based on your use case, how you want to use that. Does it make sense?
Yes.
Okay. All right. So that's about the guardrails. And I want to talk a little bit about the evals. But as I said, I don't have the execution of it, but we can still talk a bit about that. What is this? Second, let me. Okay, so let's just quickly talk about evaluation. So we did observability, right? Tracing and monitoring. So addition to that is the evaluation part. It's basically how do you evaluate or how do you test your applications. Okay. So in normal applications, when you test, right? So what do you test for? So let's say QA, right? So you do the development, you do unit testing, and then you do a QA. So for testing any functionality, let's say I have a function which adds two numbers and gives me the response. That's a simple function. Now you want to test for this. So how do you write your test case? And what are all needed to do the testing? And so what are the three parts to a test case? You're writing a test case, and in the test case, you have three important things that you should consider. What is needed to run the test case and then get the results. Now, what is the process for testing? Just a small function.
You have a test scenario, you write the test cases,
Okay, test
and step
scenario,
by
test
step,
cases.
yeah,
Expected results.
yeah.
Okay, so what do you write in the test case?
What was the use case you said?
Now, what do you write in the test case? So I know the steps, right? First you write the steps, okay?
Steps.
So when you execute, if you want to execute a test case, what do you need? And how do you know if the test case pass or failed?
It is based on the business rules.
Business rules, or rather, what do you call in the test case that rule? If you want to check for a rule, how do you evaluate that? You run the test case and then you get result. So how do you know it is passed or failed? Looking at the result. So you have to compare with what you are expecting, right?
Expected results.
Yeah, expected. Right. So basically, the three, uh, I think somebody's making put on mute. I'm hearing echo. Yeah, thank you. So there are three paths to a test, executing a test case. I know you have to write a scenario, you have to write test case, and in the test case, you write the process, the steps to follow and to run the test case. But when you actually run the test case, first thing is you have to provide an input. Okay. You are saying, okay, my function takes two numbers, adds it, and give the result. So to test that scenario or test case, I have to have an input. Input is what do I send? I need to send two numbers. Once I send those two numbers, what am I expecting the function to give? To add the number and give me. So in one of the test case, I will give, hey, pass the numbers 5 and 3. And then in the expected output column, I will say it should return me 8. So I have input variables 5 and 3. I have expected output as 8. Now I run the test. The test will give me some output. That is the actual output. There is an expected output. There is an actual output. The actual output is what is given by the function. If the function also gives me 8, and then I compare with my expected output, this is what I'm expecting, this is what I'm getting. If these two are same, then I say the test case is pass. Instead of 8, if I'm getting 7.99, right? So what is my test case, pass or fail?
Fail.
Fail, right? So let's say if I get 7.999999 or up to infinite numbers, is it pass or fail?
It still fail.
Still fail, right? So when we are talking in the deterministic world, exact values, pass, fail, true, false, based on expected and the actual output, these are the scenarios that hold. And if I run the function 100 times, I should get the value 8, output 8, all the 100 times. If I run million times, I should get 8 million times, right? So that's why I said this, the application is stable and it's good to go. These rules, when you apply to your LLM applications, they fail, right? That's still valid. Yes, no. Are they still valid if you apply the same rules to an LLM application and then put the same test cases?
Yes.
Yes. No, the scenarios are valid, but the responses, do you think it will still give you the pass fail? Does it pass? If you ask a question and an answer, expected answer and the actual answer. See, because LLMs are non-deterministic in nature, which means they kind of generate the answer every time. So you cannot obviously expect an output, exact output from the model. right from day one, we were saying if you ask
Yeah,
the question, same question twice, you would get a similar answer, but not the same answer, right? Because they are generating the tokens every time.
there
So
is no
make it
predetermined actual results, right? It varies
exactly.
every time.
So the evaluation becomes difficult because you are trying to evaluate a answer from a model which you don't know what to expect. I mean, at high level, let's say if you take a simple example of what is the uh, capital of France, that's my question. For that, I can write an expected output. What do I write an expected output? I can write France. But do you think the model will give out in one token? It might say, hey, the capital of sorry, I can say Paris, right? So the model will give you, hey, the capital of France is Paris. Or another model might give you, Paris is the capital of France. Or another model might give you, the capital of France is Paris and the Paris is known for its culture, blah, blah, blah. It can give you a 10, 15 lines description. So you, while the answer is somewhere there in the output, but you cannot expect an exact match answer for what you are expecting. So which means you can assess the correctness, the completeness, the factually correctness, right? All of these parameters, but you cannot do an exact match. So that's how the testing or evaluating LLMs is a bit different. Okay. So there are several techniques that you do to evaluate LLM models. And then all of these, as we said, right, your Langsmith, LangWatch, they all have evaluators, kind of a thing. So how do they do is basically if you have uh, LangWatch has like 30 plus in built-in evaluators. Answer matching. So you give an answer, expected answer, then there is an actual answer. So sometimes you can also do an exact match. Um, some cases, if you want, if you are very sure, let's say I put a calculation, right? So you can also do an exact match, say, hey, just give me this number from this document or whatever. Where it is required accuracy, you can add that as well. But most popular scenarios, most of the times scenarios is LLM as judged. So LLM as judge, what it does is, as we said, it will make sure overall, the answer is similar, the correct, factual, complete, correct, right? So all of these parameters it will check for in the answer. So what you do, you have an input and then you also put an expected output. Now you pass the question to a model, the model will give you an output. Now you have three attributes: input, actual output, and expected output. So you cannot directly match the output and the expected output. So what you do is you send all these three to another model, which you will choose to act as a judge. So that model will take, hey, this is the question, and this is what the user is expecting output, and this is what a model has given as output. Now it will compare these two with respect to the question, and then it will evaluate and give you, yes, this answer is correct, truthful, complete, whatever the kind of parameters that you choose from, and that will judge and tell you whether it is correct or not. So that is one of the uh, strategies that is used for testing. Call it as LLM as judge. So you are using one LLM to judge the work of another LLM. Sometimes, most of the time, these are different models. You don't use the same model, then there is no point of doing it. So you are, let's say, using a 4.0 mini kind of a thing, and then you can use a higher model 5.2 to judge, the answers, or you can use Claude model, Anthropic Claude or Sonnet to judge your GPT model, something like that. So it's like external validator. Then you can do RAG quality, correctness, completeness, format and quality, safety, custom checks. There are some NLP metrics like Blue and Rogue. values that you can calculate. So all of these are there. So we'll just quickly go through what are the strategies here. And then in the next session, we'll try to run some of the evaluations and a time permits. We said exact match. This is the standard our QA test scenario. Like we said, 6 into 7 must equal 42. API return success. Exactly is what is the response of API. Like it should respond 40 or 200 for success, right? So you can match that. Date parsing, you can some of these or the exact match evaluators you can use. Answer match is what we talked about, right? Semantically correct. Let's say store opens at 9 a.m. is what some questions the user is asking, what time does the store open? And I'm giving the expected answer. It's a I have a document for the store where the model is reading from, the RAG is reading from. I'm giving answer in the chatbot to the user. Store opens at 9 a.m. Or the model might be responding with we open at 9 a.m. in the morning. So this is what might be in the text, or this is what is coming out. So these two are almost semantically same. I mean, right? Both convey the same meaning. If they are not, the words are not exactly same, but the meaning is same. So this might be a pass, a scenario, test case passed. Sometimes a car, it might generate automobile. Sometimes it's reset password online. Then it might say change password via portal. So these are all like when you give it another model to check the expected answer and the actual answer, it might compare these two and say this is a pass. Okay. Blue Road evaluators is like for the natural language processing. Just to know that these are the indicators, you don't need to go deep into this and understand. These are how good your models are performing at translating the natural language. Right? Machine translation, say from from French to English. Model summary versus human reference, human versus AI headline similarity. So you can compare the text both, and it will give you some metrics, statistically, how your model is performing based on the blue and rogue indicators. Okay, so these are natural language processing performance indicators, you can say. So you don't need to do this most of the time, but just it'll be good to know. Factual match, as I said, capital of France, it should output Paris or somewhere similar to that. Paris should be there. It cannot just do something. So it must be 4. It must be H2O. It cannot say O2H or something like this. Right? So these are also, it should be factually correct. Ensure 2 SQL queries are semantically equivalent. So this happens, right, when you, let's say you're writing a use case. We have also done this use case called chat with data. It's very popular. Every company is doing their own internal uh, chat with data applications. They call it SQL agent, they call it chatbot, chat with data, whatever they call. Basically, you are converting English questions into a SQL and then running that SQL against database, getting the results, and then generating visualizations. So that's the use case, end-to-end use case. We have also built one at our work. Now, when it is generating the SQL, how do you have to do a lot of evaluations, whether the SQL is correct, whether it is referring to the correct tables, referring to correct columns when it is calculating, right? So there might be different columns for sales. So it might be in the USD, it might be in the local currency. So which column it is picking? Or let's say you're calculating average sales. Is it calculating the formula properly, taking appropriate aggregations correctly, right? So all of that has to be evaluated. So when this, um, the model will generate a SQL based on your English text. Now, how do you know that SQL is correct or not? That's the first step to evaluate that SQL. So most of the times you can write some of the test cases yourself, give some questions, and write SQL yourself because you know you have domain knowledge. You write the SQL. Same thing. Again, you run it to the model. Model will give you some output SQL. Then you have to compare your expected SQL and the actual SQL that was generated. So when you're comparing these two, again, the SQLs may not be exactly same because there are n number of ways to write, multiple ways to write the same SQL, right? So I can write a inner join or I can write a inner query, subquery basically. As long as they both give me the same results, they are okay, right? And then aliases, table aliases might be different. And then where clauses might be different, filters might be different, group bys might be different. So all of this, the different ways of writing the same SQL, but again, they have to syntactically they should be correct. They should give you the same results. So those kind of evaluation you have to do. Select name is very versus same query with different syntax. Okay. Select count star versus select sum from cells. So count is different from sum, right? Count will give you the number of rows. Sum will add all of the cells and give you. So you have to see whether the syntax is correct or not. Is it giving the same output or not? Okay. So that is what the SQL equals. The Boolean is okay, true, false. It will give you a true, false. Category, tone, sentiment, style. There are so many evaluators. We don't need to, it's just a list of it to go through score evaluator, rubric, context precision, context recall, faithfulness. Right. There are several scenarios here. If you want, I can add this deck also. You can go through valid format. If it is giving the JSON format as expected or not, it is is the response JSON valid JSON or not. So all of this you can validate. Language detection, summarization, safety and compliance. Right. So this is several ways of doing it. As I said, just creating once again. Okay. So if you go to Langsmith, the other day we did tracing and monitoring. So as I said, there is also evaluators here. So what are these evaluators? Some of these we have seen in the guardrails as well. So you can also evaluate before putting in the guardrails. You can check for prompt injection, PII, toxicity, bias, all of this. You can, your guardrails will protect, will check runtime basically in production. If there is something that is coming in, they will block it or do it in the production. So guardrails go into the production. Evaluators is your testing before putting into production. Sometimes you can also add it into production to get the logs, but evaluation is before you put into production, you check your systems, whether there is a PI leakage happening or whether there's a prompt injection happening within the models or within the application, within the of course, you will not have all the prompt that user will give, but based on your test prompts that you do for testing, you can evaluate how your models are performing and improve them. And then finally, you put guardrails and put it into production. So you can use both, right? So if you say PII leakage, whether output contains PII from the model, how to create this is basically this is the prompt you give, names, contact information, financial data, all of this. These are considered sensitive and these are not considered sensitive. These are the instructions, the gold rule, all of this. Then you give example input and output. So based on this, you can create a evaluator and use it to test your application. This is a little bit complicated, a little bit complex, but you don't need to look at this. We'll see if you want to, but you just need to know how to use all of this, how to at least know how to what are the strategies to evaluate your model. As I said, there's a LLM as a judge evaluator. Okay, again, how to use this evaluator, how to create this evaluator. These are, templates. You have to configure this evaluator and create. So there will be some, these are all the templates you create evaluators, personal evaluators, but there will be some evaluators available uh, off the shelf. Okay, so if you go to, just deleted. So if you go to language, there's like evaluations. It'll look like this: eval demo, evaluation wizard. So you can choose a data set for your testing. Okay, then execution method. It's not saving. Yeah, we'll just go through this and we'll come back and revisit later. Want to create a prompt. Okay, I don't know. This are all disabled for me. Maybe I'll have to check this again. Normally you have to create a workflow, but I think the workflow is disabled. This is LLM prompt. Okay, I'm not sure. So this is having some issues. We'll check that. But basically, you can go and create something like this, okay, to verify this. If you go to workflows, go to PI detection. So if you see here, these are all the data sets. This is the data set that I have created with the 10 rows. Okay. And this is the PI detection I'm doing. So I'm selected all of this, just like your guardrails only. So I'm asking all of these to detect in the okay. So this is the input. Every time it will run for one input and it will give out a Boolean value. Okay. And then we'll just say take output as Boolean here because it is coming as Boolean. Okay. And then experiment runs. So I'll just say evaluate workflow. Save and run evaluation. So these are all the different runs that you can do experiments. So this is run 5. So score is 1, status failed. PII detection detected, person, likelihood 0.85. Okay. So because it's a John Smith, it identified there is a PII information, person. Uh, Send the invoice to Sarah Johnson. Again, PI detection, email address. It says it found, yeah, this email address as PI information. The server logs here, IP address. It found a IP address in this record. Here it found location, phone number. So all of this, it gives, the PI detection that ran on all the 10 records, if you see. For each record, it gave you the score, how many it has found. So in this, it found IBAN code, location, phone number, and person, 4 elements. So its score is 4. Some places it found only 1, so it just found only the person. Of course, there is this card number. It didn't detect the card number here. Okay, so that is how you do the evaluation, the QA testing part when you are testing your models. So if you see here, so these are all you can switch on what you are checking for the inputs, your score. Okay, so that's about how you go and evaluate these workflows. The slang watch is a little bit confusing. It's not very intuitive to use, but this is good enough to know the concepts, basically, how do you do the evaluations. If you go back here just a little bit, if you go to this workflow simple rag, so you can see what it does, right? Again, you have data set about 82 rows. You can select, create your own data sets. You're generating a query, generate query question, and call but v2. And what this is, URL wiki 17 abstracts. It generates an answer from this, and then you are sending the exact match, answer exact match to this output and the expected output. So you get a past Boolean values. Okay. So you have a question, you have a gold answer. Now it's taking the same question and it's generating a short Wikipedia search query to find info about it. So basically, you're taking a query, a question, you are sending that query to Wikipedia using callbut v2. So this is the URL for wiki abstracts. You're getting an answer from there, and the answer you are getting, generated answer, and your gold answer you are passing for the exact match here. So this is the entire workflow if you want to test any of your rack. Basically external to your own answer, you are checking if the model is able to go to wiki, get the answer, and then you are comparing your answer and from the answer that is getting from the Wikipedia. Okay, I don't know if this still valid. We'll see. Okay, so when you run this, okay, retrievers are no longer supported. Use the code block instead. Okay, this is not valid. Yeah, this is not very stable. They keep changing it, and then because we are using test account, something might be not proper. But see, the overall process remains same. The components might be little outdated, and then you have to go back and fix or create paid account or whatever. But it will give you. So this is the overall sense of how it works. All right. So that is about the guardrails and evaluation. As well, I'll share all the notebook and recording, and probably the deck. You can review that. So next week, hopefully, we'll get back to our deployment project and also talk about MCP and A2A. All right. Okay, I think that is for today. Any questions before we wrap up?
No, Arun, thank you.
Okay. All right, guys. Thank you so much. Appreciate your time. Have a good rest of the day. See you next week.
Thanks. Bye.
Thank you. Take care. Bye.